So you want to find out how big the sun is compared to other stars? Stick around, we're going to find out. Hello! So, we're going to find out how big the sun is compared to other stars. And we're going to start with the sun, which is a yellow dwarf. Bit of a funny name for a big star like the sun, but that's what it's called, a yellow dwarf. Now, compared to the Earth, it is an apple seed. Okay, I'll show you that so you can see it. An apple pip. I don't know if you can see that. So that's the scale. To give you scale of the balloon, or the balloons that we're going to be using, 36 inches across. Okay, so quite big balloons. I'm exhausted after blowing them all up. What can I tell you about the sun? Well, the sun is incredibly big from one side to the other. If you were travelling in a Boeing 747 at 500 miles an hour, it'd take you about 2 months to get there. Ridiculous. Massive. So let's find out what Earth tastes like. Apple pip. Delicious. More. So that's the sun. So I thought it would be good to give you a scale of the Earth compared to the sun. But we're going to look at stars. Now the first star that we're going to look at is actually one of my favourites, kind of Neutron Star. Okay, I'm going to pick it up. It's actually represented by a flake of chili. My favourite. Don't like chili. So that's the scale of the Earth. We're going to turn this into the Earth. This is a neutron star. It's really, really small. In fact, this doesn't really give you scale. It's about 12 miles across. Okay, very, very dense. What happens is actually from a very, very large star. So a very large star is dying. It collapses in on itself. It either turns into a neutron star or a black hole. But this one's a neutron star. Very, very dense. All the atoms, the electrons, the protons, they all turn into neutrons. And they think has a hard case. So if we blow the neutron star up to this size, they think it's going to be a hard outer surface, which would be made up of, they think, neutron crystals or something like that. So super dense. One spoonful of a neutron star is the equivalent of the weight of Mount Everest. Really, really huge. So what's it taste like? It's a chili flake. I don't like chili. Can't taste anything. Oh yes, I can taste it now. Lovely. So that was a neutron star. We're going to work from the smallest up to the largest. The next one is a white dwarf. A lot of dwarves going on here. So represented by a lemon pip. That's the scale. I don't know if you can see it. A lemon pip. Now this, okay, is, there we go, this a lemon pip. About the same size as Earth, just a little bit bigger. So look, there they are, the two of them. Ta-da! Interesting about white dwarfs, it's what the sun is going to turn into in billions of years' time. Don't worry. It's not going to happen in our lifetimes, or anyone's lifetime for that. It's going to happen a very, very, very long time from now. And they're very dense, not as dense as neutron stars. But what happens is the sun grows into a red giant, which I'll come on to in a minute. And then it sheds its outer layers and it turns into a white dwarf in the middle. Let's taste it. Super. So that is a white dwarf. Hot white star. Small. The next one is this lovely, lovely red cabbage. Rather a large red cabbage. Now what's this? This is a brown dwarf. Another dwarf. Very, very fascinating, this one. It's very cool. Now your oven at home probably gets up to about 300 degrees Celsius. This doesn't even get to 100 degrees Celsius. Okay, so it's very, very cool. In fact, ta-da! about as hot as a freshly made cup of coffee. So when you see people walking around with a cup of coffee, you can tell them that fact. So fascinating. It tastes like coleslaw. Wonderful. That's the scow. This is now the sun, and this is a brown dwarf. There we go. Quite a bit smaller than the sun. The next star we're going to talk about is a red dwarf. Another dwarf. That's the scow. Sun, red dwarf. Sun, red dwarf. So, represented by my trusty watermelon. What can I tell you about this star? Well, I can tell you that it's our nearest one. There's lots of red dwarfs in the universe, but one happens to be our nearest. It's Proxima Centauri. It's 4 light years away, so it would take you 4 years to get there at the speed of light. Speed of light, 299,000 kilometers per second, or 186,000 miles per second. Really quick. Fact for you, if you were going to travel there by car, I wouldn't recommend it. It would take you 43 million years to get there, travelling at 70 miles an hour. So loads of packed lunches, loads of ball games, don't do it. So that is the scow of the red dwarf, and let's see what it tastes like. Can't get in there. Not nice, don't do it. So that's the red dwarf. From here on in, the sun actually gets a lot smaller. Now I'm going to get rid of the yellow dwarf, our sun. I'm going to replace it with another balloon. Now this is going to be a red giant. This is no longer the sun, it's a red giant, and the sun is going to be represented by a radish, my favourite. Lovely. That's the scow. That is the scow of a red giant compared to the sun. Now what's interesting about this is, I mentioned it earlier, is that this is what the sun is going to end up like. It will burn its hydrogen, it will burn its helium, it will get bigger and bigger and bigger, and it will turn into a red giant. And then, over billions of years, this is going to happen maybe in 4 billion years' time. We won't be around, so don't worry. But what will happen is it will shed all of its layers of gas and it will turn into a nebula. And hopefully you'll see some nebula on the screen now, which will show you perhaps what the sun will turn into. And at the centre is that white dwarf I spoke about earlier. Okay, and let's see what a radish tastes like. Oh. Delicious. Spot on, just what I needed. So, we're going to swap the red giant for a blue supergiant. No expense spared here. Now what you'll find with stars is not only are they different shapes and sizes, they're different colours, and there's a reason for that. Blue tends to be the hottest of stars, certainly the case for a supergiant blue star like this. Doesn't last long because it's burning more energy. It could last 10 million years, it could last 200 million years. You can see one. Go to the Orion constellation, best in around about the winter time, and you'll see as you're looking at Orion, it will be the right foot, a big blue star called Regal, 860 light years away. 860, wow. Loads of packed lunches, loads more ball games. So very, very hot, very big. There's the scow. Wow. I'm a gooseberry. There we go. Gooseberry. Gooseberry. So that's the scow. This is the sun compared to a blue supergiant. And it tastes really good. Just getting that radish out of the way. Beautiful. My dessert. So the next star, I'm going to keep this one here, actually, because the next biggest stars are the hypergiants, the blue hypergiants. Colossal, represented by a pepper seed or a capsicum seed. Don't think you can see that, I'm not sure. So very, very, very small. Can't even taste it, it's gone. So the sun was that capsicum seed or that pepper seed. Colossal, absolutely. One thing you should know, if you go to visit a hypergiant, wear shades. It's extremely bright. In fact, it's 600,000 times brighter than the sun. And it's hot, so take factor 50,000 with you as well. So, amazing stars. For the next star, we're going to get rid of the blue one and we're going to replace it with a purple one. No, we're not really. We're going to replace it with the red one again. And these stars are the biggest. They are super red giants. Super red giants. The scale, it's just amazing. It would be the sun being a poppy seed. Okay, so poppy seed. Gone. The sun has disappeared. So the scale, if one of these were at the centre of our solar system, so you took the sun out and you replaced it with a super red giant, it would be immense. There would be no Earth, the Earth would be frazzled. Mars, Jupiter, it would probably be touching on Saturn's orbit. So massive. There is one that you can see, it's in Orion constellation again. It's called Betelgeuse. It's the top left star of his shoulder. It's a big red supergiant at the end of its life. It's about to go supernova in the next 100,000 years. Stick around for that. So they're the stars. There was one other star called a quasi-star. It's a hypothetical star at the start of the universe. The first few million years, they think quasi-stars came around. They were giant. So if you swapped the sun for a quasi-star, you stuck it in the middle of our solar system, took the sun out, it would probably go beyond the orbit of Pluto. So astonishing. So that's it. A very quick, scale of stars. Do subscribe. There's going to be loads more videos. Just one final thought. We're all made of star stuff. Everything you see, everybody you know, we all came out of stars. We're all the same. So there's a thought for you. Have a great day.